Let's start by installing FrameMotion. We'll open a new terminal window, make sure that we're inside the project directory, and then run yarn add FrameMotion. When yarn is done installing, we can start the development server with yarn start, and now we're ready to make our first animation. I'm going to open a sandbox component and navigate to /sandbox route. Here we have this simple blue div element, so let's see how we can animate it. The first thing that we need to keep in mind is that FrameMotion lets us animate only motion primitives. On the web, we deal with DOM primitives, like divs, spans, and buttons, and those primitives don't have the properties required by FrameMotion to run the animations. For that reason, we need to use motion-enhanced versions of DOM primitives. So every time we want to animate something, we'll start by importing a motion object from FrameMotion, and then replace DOM primitives with their motion counterparts. In this case, we'll replace this div with a motion div. To create a basic animation, we're going to add animate property and set it to an object. This object will contain the properties that we want to animate and their target values. I'll set the width to 300 and save the changes, and when the page refreshes, we're going to see our first animation. Let's also set opacity to 0.5, save the changes, and now our box also gets semi-transparent. There is a lot of small things happening here, so let's talk about how this animation works. When component gets mounted, FrameMotion is going to see that we want to animate width to 300 and opacity to 0.5. Since we don't specify the initial values for width and opacity, FrameMotion will try to infer them. So first, it will look into CSS styles of this element. Inside CSS, we set width to 10 rems, which is equal to 100 pixels. So FrameMotion will use that value as the starting value and animate it up to 300. In case of opacity, we don't specify its initial value explicitly. But since DOM elements have opacity of 1 by default, FrameMotion will animate from it to 0.5. If we want, we can specify initial values using initial prop. For example, we can invert the current animation by setting initial width to 300 and opacity to 0.5, and then animating them to 100 and 1 respectively. Now let's try a few more properties. I'm going to remove width and opacity animations and instead set background color to soft pink and border radius to 20. When I save the changes, we can see that both animations work as expected. So far we've animated just a few properties, but in general we can animate any CSS property as long as we can interpolate its value. Interpolation means that when we change some property from value A to value B, we can also find intermediate values between them. For instance, when we animate the width from 100 to 300 pixels, we have a numeric scale. And when we animate the background color using hex values, we have a gradient scale, and we can find intermediate values on both scales pretty easily. By contrast, property like visibility cannot be animated, because it can have only discrete values, like visible and hidden, and on a scale from visible to hidden, there are no partially visible values. For the same reason, we can't animate colors using their names, because values like blue and pink are also discrete and cannot produce a scale. So instead we have to use hex, RGB or HSL values. FrameMotion also lets us use different units for the animations. When we set value to a number, like we do here with the border radius, FrameMotion will assume that we want to use pixels. To use any other unit, we can set the value to a string and specify the unit explicitly. For instance, let's set border radius to 50%, save the changes and see our animation. Next, let's take a look at how we can animate transform properties. To change the position of the element, we can set transform to translate y 60 pixels, translate x 60 pixels, which will move the box 60 pixels down and to the right. As you can see, even though our animatable value is a complex string, FrameMotion can interpolate it just fine. Now, transform animations are very widely used, and since it is quite cumbersome to type this long transform string every time, FrameMotion gives us a few shortcuts. So instead of writing this string, we can set x and y properties to 60, and this will achieve the same result. Some other frequently used transform property shortcuts are scale, which takes a scale coefficient, and rotate, which takes an angle in degrees. One thing that sets FrameMotion apart from other React animation libraries is its ability to deal with different units. Properties like width, height, X and Y can be animated across different units without any issues. We've already animated box width from rems to pixels, but we can use even more complex values. So if we set width to a calculated value, for instance, animation will work just fine. Okay, so far all our animations ran only on initial component mount, but we can also animate things when the component state changes. To demonstrate that, let's add a local state variable called expanded using state hook with the initial value of false. Then I'll add an onClick handler that will flip its value. And finally, set width to the calculated value if expanded variable is true, and to 100 otherwise. Then I'm going to save the changes and refresh the page. So as you can see, we no longer get the animation on mount because expanded variable is initially set to false, so the target width of the box matches its initial width. When I click on the element, the value of expanded variable is going to flip from false to true, so the width will have to be animated from its current 100 pixels to our calculated value. Alright, now let's see how we can apply what we've learned in the main application. We'll start by navigating to the root path and opening a header component. Header component has two buttons that allow us to change the order of pictures. To indicate which sorting order is currently active, we append an active class to the button. We can open styles.scss file and see that sorting buttons have opacity of 0.3, which changes to 1 when we add active class on them. Instead of going from 0.3 to 1 instantly, let's animate that change using FrameMotion. So first I'm going to remove active class and opacity value from styles, and also get rid of this logic that appends active class. Then I'll import motion from FrameMotion, replace buttons with motion buttons, and use initial property to set the opacity to 0.3 for both buttons. Finally, we'll add animate property to the first button and set it to 1 if the current order equals rating, and then we'll copy it over to the second button and change the condition to order equals views. Now we can save the changes and confirm that when we change sorting order, one button fades out while another one fades in. Now let's also make some changes in Modal component. Right now, if we click on a thumbnail to trigger the model just appears, and without any transition, it looks jarring. To fix that, I'm going to import motion from FrameMotion again, and then replace overlay and panel divs with motion divs. For our animation, we want the overlay to gradually fade in. So I'll set its initial opacity to 0 and animate it back up to 1. Then for the panel, we want it to pop up from the bottom. So we'll position it off screen by setting initial prop Y to 1000 and then animate it back to 0. Let's save the changes and see the result. While this looks a lot better, there are still a couple of issues. First, when we close the model, it still just disappears without any animation, and it would be nice if it slid down the same way it appeared. Second issue is that when model pops up, there is a slight overshooting, so we get a small gap under the panel. We're going to address both of these issues later in the course.